All right, so right now we're going to try to graph a function, a rational function actually, and this one is x squared plus x minus 12 over x squared minus 4. Okay, just for now, I'm going to factor those out for us because we're glad we did that a little later. Whoop, a little later in the problem. Okay, so the numerator becomes x plus 4 when I factor it times x minus 3, and the denominator is difference of squares, so that's going to factor out x plus 2, x minus 2. Okay. All right, now, if you have to graph a function like this, the first thing you want to find really three things. The intercepts, okay, the vertical asymptotes and the horizontal asymptotes, or horizontal or oblique. Okay, so if I look at this one, let's start with the easy stuff, okay? When I look at the degree, look at before I factored, okay? Degree on top and the degree on the bottom are the same. So your vertical asymptote is, your horizontal asymptote, I take that back, would be y equals lead coefficient over lead coefficient, so y equals 1. Okay, now let's do vertical asymptotes. Vertical asymptotes happen, there was nothing up here, let's look at the factored form now. There was nothing that I could cancel out, so each one of these factors, when they're 0, they leave that function undefined. So that's where your vertical asymptotes are going to be. So you're going to have, because of this factor, x equals negative 2 is one of your vertical asymptotes, and then because of this factor, you have also one at x equals 2. Okay, the very last thing you want to do is find the intercepts. Okay, x-intercepts you find when y equals 0, and y-intercepts you find when x is 0. So let's start, let's let y be 0. Okay, that only happens when my numerator is 0. So if you look at the numerator, okay, this will be 0 when x is negative 4, but you can also get a 0 in the numerator because of this factor at 3. So now you have your two x-intercepts. Now the y-intercept, comes from when you let x be 0. So if you actually go, you can go into either form, but let's just say you put a 0 in for x here, you'd have 0 squared plus 0 minus 12 over 0 squared minus 4, which would be negative 12 over negative 4, which is 3. So you also have the y-intercept 0, 3. So you've got all your intercepts done. You got two vertical asymptotes and a horizontal asymptote. So let's see what that gets us. Let's bear all that in mind. I'm kind of liking the red marker, so I'm going to keep that. Okay, from the previous page, you got negative 4 comma 0. You have 3, 0, and you have 0, 3 as your intercepts. And then your vertical asymptotes, there's two of them, x equals 2 and x equals negative 2. And then horizontal asymptote is y equals 1. And if there's a horizontal asymptote, there is no oblique. So let's get ourselves a little graph going. Okay. And again, these do not have to be perfect. I just want to know that you can tell me the general shape of these guys. So here we go. Okay, starting, I'm just going to plot all three of these points up here. So negative 4, 0 will be right about here. 3, 0 is right about here. And 0, 3. They're all on there. Okay, so that's done. Now let's plot let's go ahead and do our vertical asymptotes. So at x equals negative 2 would be right here. Okay, x equaled 2 would be here. Okay, and then thirdly, your horizontal asymptote right there. Okay, that would be right here through y equals 1. Okay. Now if you need to plot a couple other, we're going to start in this lower left-hand corner. You know you have a point right here. If you need to, you could plot a couple other ones, but you're always going to, as you go towards negative infinity, you're always going to tend towards the horizontal asymptote. And then obviously as you go to the right, you're going towards that vertical asymptote by the same logic. And again, if you want to plot a couple of points, you can, but these are going to kind of those vertical asymptotes, you can never cross them, so they kind of act like electric fences. Okay, and then again, you have this third point right here, so same logic, you're going to go down here and up here. Of course, you can always check that on your graphing calculator.